All right, hello. I'm back from 2 weeks of travel and gonna try and go back to mostly weekly live streams. There's gonna be a bit of a gap in a couple of weeks, but otherwise I'm back. I saw the cat just outside the room, so I'm just gonna bring him in very quickly for those who want to see the cat, and then close the door and we'll get going. And here is the beast. He was just hanging out in front of the door, so I figured I'd bring him in. But he's probably gonna go on the other side of the door for the rest of the live stream. So say hi, and I'll go bring him back. All right, that should be Jared being happy to see the cat. And now let's look at Incus OS and where we stand. Oops, my laptop is making noise behind me. Hold on. Alright, I should take care of that. Cool. So yeah, Incus OS. I've done a bit of work over my trip to Europe the past couple of weeks. And the next step is going to be, as mentioned in the stream title, to add systemd-sysext support to it. But yeah, first let's take a quick look at what happened. So just as a quick reminder, Incus OS is an immutable Linux OS image based on Debian testing, whose only job is to get a Incus system up and running as quickly as possible. It does a bunch of the more modern things, so it's obviously all like completely immutable. It sets up secure boot for you. It does TPM measurement so that the persistent storage can be automatically encrypted. It does kind of all of those kind of nice things for us, and it's using make OSI as a way to build those images very easily. So where are we at? Well, in the last live stream, I think I made it. I think we had the manifest already, and I think that probably was it. We were probably around this point here. What I've done since, I actually had to set up the building on my laptop, so I noticed we needed to add a bit more logic to actually bail properly if make OSI is not available. So that's the first thing I added. Then I made it so we also enroll an empty key into the encrypted partition. That's because on most systems, there's a bit of a bug right now with the one of the EFI package, SB sign util or something, which makes it fail to actually enroll the secure boot key on first boot. So you end up with that annoying behavior with Incus OS boots properly, everything works, but if you reboot it, you don't have persistent storage, and there's no way for you to get access to the persistent storage ever again. So to fix that, we now enroll an empty key, so it will prompt in that scenario, if it can't unlock it automatically through TPM, it will prompt for a recovery key, which is just empty. You hit enter and it's fine. Obviously not something we want to keep using in production, but in production we still want to use a recovery key, so effectively that empty slot will then get replaced by a unique key for you to safely keep around in case the TPM state no longer matches and needs to manually recover the storage. Then we've added a bunch of systemd packages, again mostly kind of related to partitioning and like. So systemd crypt setup is now there, so that lets us actually play with that TPM, well, encrypted storage slot where we've loaded the empty key. Added resolved and timesync, so we've got the full kind of network services stack. There's no network config in place yet, but we're getting there. And added systemd repart, which allows for a bit repartitioning. Again, doesn't make sense right now, but will make sense once we start doing systemd, what's the name? Sysupdate, so the AB update system. All right. Then I doubled the ESP size. The ESP size is the EFI system partition. and had to double that size because our UKI, so kernel plus init are the images, they're around 500 megs. The partition was a gig large. So as soon as we start adding sysupdate to the mix where we need AB, it's not gonna fit. So I doubled it to 2 gigs, which should fix that. It's a bit of a problem that the UKI is 500 megs large right now. We'll want to trim that, like ideally locate a whole bunch of kernel modules that make no sense whatsoever on an Incus host. So it could be like potentially a bunch of USB drivers, also a bunch of GPIOs, a whole bunch of other stuff like that. We need to figure out what's the biggest bang for the buck as far as what can we just remove and clear up a bunch of space. Down the line, we might get a custom kernel config for this that's more targeted to running like on physical machines. But for now, we'll just keep the kernel we have. Then, since with the early boot stuff is mostly fine, I went ahead and added some logic, just added the quiet and splash keywords to make the boot a lot less verbose. So that just helps there. Then we've also added Plymouth, which will eventually let us do like an actual splash screen. Currently, it's not actually fully running and integrated yet, but it's installed at least. Then I did a bit of a trick so we don't keep re-downloading the same keyring while we build the image. And lastly, and that's kind of the preamble for this live stream, is added logic to install all of the Incus dependencies, but not Incus itself. So it's a bit of a trick. We start by installing the recommended things directly, because those will not be pulled through normal package installs. Or if we were to, it would pull more than just that set. So anyway, we install that set. And then we've got a bit of a script that adds the Incus table repo, which then installs Incus in Incus UI canonical, and then proceeds to mark everything as manually installed and then purge Incus from the system. So it's a bit of a weird trick where effectively we fully install Incus just to yank it out. But when we yank it out from the system, what we have left behind are all of the dependencies. And the reason why we do this is we want to have 2 different images. We want to have the base OS image. So that's the one that's, that's the Debian testing base, our kernel, and the systemd stack that we need for those images, and then every single dependency of Incus. So that's what we've got in the base image. Any change to that base image requires a reboot. Then we've got Incus itself that we want as a separate image layered on top of this, which can be updated independently. So this is going to be pretty, it's going to be a pretty common operation that people will have to do because you might just get like a Incus cherry pick or just a new minor release or something like that, and that layer will be changing. The reason why we do it that way is because if you're in a cluster, you need to be able to decouple the two. In a cluster, an OS update can be done by evacuating a server, at which point it's got nothing running on it. You can reboot it and then restore the workloads on top of it. That works pretty well. You can do that weekly or whenever you've got security updates to the base OS. For Incus, we can update at any point. It doesn't bring any of the workloads down, including major updates. We can just do it live. The catch on the Incus side is every machine in the cluster needs to update in lockstep if we are doing a database change. So most of the time, not really going to be a problem. But if we do have a major Incus version change that comes with a database change, then as I said, all of them need to be updated at the same time. That's fine if the two are decoupled, because we can just go and update that Incus system extension image on all machines. None of them need to be rebooted. None of the workloads get impacted during that update, and everything's fine. And then if there's an OS image as well, an OS image update as well, then you can do the rolling reboot for that. If we were to do a single image with Incus pre-baked in it, it would work fine most of the time, where, okay, Incus would be updated as part of an OS image update. So long as there's no database change, you can just go and do your rolling update one machine at a time. And once the last one updates, hey, you're now on the new version. That's great. But the moment a database update becomes needed, that doesn't work. And now you need to actually effectively shut down everything on your cluster, like shut down every single workload, because there's no way for you to evacuate one by one to do that update. As soon as you start doing the updates, the other machines will refuse to do anything until the update is completed. So that effectively, forces you to stop everything, do the update, reboot everything, and then restore, start back all of the instances. That's obviously not something you ever want to do in production, so that's why we're decoupling the two. Just looking at chat here. Oh yeah, so someone been playing with Keras or Keras, I'm not sure how to pronounce that, and stripping firmware kernel modules and then add Incus. Yeah, we're gonna have to do most of the same thing. The main benefit we're gonna have is that the kernel we're using is actually mine, so it's the one coming from the Zabli repo. We will probably have a different flavor of that kernel down the line, which is targeted specifically to running Incus as opposed to running on top of Incus or the like. It's not impossible. Eventually we'll effectively have 3 flavors, one being the generic config, which is what I've got right now. It's effectively an Ubuntu style config, all modules enabled, works everywhere, does everything, it's great. It would make sense to have another config which is targeted specifically to running as a host, which means having just enough, PCI support and USB support and the like to be able to do device pass-through to VMs or to containers, but we don't need every single driver in existence to be there. We also don't need, like, some of the most massive subsystems can just go away entirely because we really don't need them. Like, we don't need any kind of 3D acceleration type stuff, all that can go away. And we can also be quite a bit more selective on, like, minimum CPU generation supported. So if you can bump that a bunch, you can actually get some extra performance on recent hardware. So we would be able to do that. We'd be able to, effectively shrink that kernel down to probably a quarter of its size, if not even smaller than this. And then another thing we could do is generate a kernel meant to run in the guest, which could also be absolutely tiny, because then it would just be Linux, basic Linux kernel. Same thing as far as restriction for the CPU generation, so be something reasonably recent. And then on the driver side, that's where you really get to remove most things, because you basically just need .io. You might need some of the most common pass-through devices. Like, you might still want to have some amount of the GPU stuff be allowed, be supported, and some amount of the network devices supported for NIC pass-through. But yeah, in general, that would result in very tiny kernels. The problem with that, obviously, is now instead of having to build and maintain and test one kernel, I would have to build and maintain 2, if not 3 kernels. So the first stage is going to be effectively what you've described in the chat, which is just strip a bunch of stuff out of the existing kernel builds, like just remove the .kos and the like, to shrink this instead of actually building a new kernel at this stage. So anyway, that's where we stand right now with the image. And it builds, it boots. That's all fine. Let me check. I think I actually have it. I think I actually do have it currently running. Let's see, dev Incus OS. Nope, I don't. Am I in the right project? Oh, it's test Incus OS. Yeah. Okay. Test Incus OS. Yeah. Okay. So it is running. We can see, as usual, we pretty much only have the systemd stuff running. The one exception is now we've got LVM logd here that's also running. And I noticed that I need to actually see how to best fix that. But on boot, there was a systemd unit that failed now, which is, actually too. Well, that's because of a reboot. Okay. So as I mentioned, with the TPM state not being correct on the second boot. And then NF tables also failed to start. That's fine. We don't actually want the NF tables stuff to start, but we just need to actually rip it out so it doesn't even try to start. I think it would probably be user grep NF table systemd. Yeah, okay. So we just need to get rid of that unit. Let's do that quickly. Oops, Incus OS, not Incus itself. Okay, and Mac OS I conf.d. Not sure if I've done that stuff in cleanup. No. Incus deps. We could just do it in Incus deps. That's fine. What's the syntax for removing stuff? Remove files and content. Okay, cool. So let's go here and we do remove files, and then this guy goes away. Okay, so in theory, that shouldn't get us an image without that particular unit, and that will take care of that issue. I mean, not really an issue. I just like systemd failed to be empty on boot. There's no point in starting any kind of services that are not strictly needed. Alright. Yeah, and I just mentioned the size of the UKI, and yeah, it's quite huge right now. Do we actually have the boot partition mounted at all? I don't know if we do. Let me check. SDA. It's done in GME. Nope. Okay. Yeah, because it is not mounted. Okay, so I'll just go ahead and mount what should be the mount partition. Yeah, I don't have a mount folder really. Actually, I don't. Okay, well, let's abuse this. This is a bad idea, but whatever. It's been found. Yeah, there we go. So we can see. Okay, so the UKI would be in. I don't remember where it is. Is it in EFI? It's a bit of a mess in here. I mean, also don't strictly need a separate kernel in Iterating, so we're kind of just duplicating space needlessly. So I might also tweak that to just gain back a bunch of space. But yeah, the UKI we're actually loading is this guy. Copy paste not behaving. Okay, so yeah, 557 megs is what we're dealing with. And there's a bunch of duplication, as we can see. I'm actually not sure why it ends up being so large. Oh, it's because, okay, yeah, no, I think those are just basic kernel init.rd from the package, but then makeOSI builds us a custom init.rd, which is much bigger because it actually pulls everything in, whereas this one is just what Debian pulls in. So there's some tweaking we can do. I know it's possible to tell makeOSI to effectively already do a kernel module selection. When we did in the past, it didn't work. It was missing some stuff, but we won't be able to tweak it enough to actually just take care of most of that problem, because this is a functional init.rd. Like, I know that's most systems will boot with that just fine. It's 58 megs large, so there's no reason for the UKI to be 10 times that size. Anyways, so that's where we stand now for syssext itself. So syssext is systemd's kind of system extension layering mechanism with the systemd man page here that kind of covers that stuff. So you can do confext, which I believe layers on top of /etc and /var, and sysext, which then layers on top of user or opt. In the case of the Incus package, it's fine. We are basically only shipping files in user and opt, so that should be perfectly fine as a sysext image. It's using overlayfs to combine things. That's fine. That's kind of what we're used to. It's very similar to like layers in the application container world, effectively. And I think the advantage is that we can sysext images can also use the same security features as everything else. So you can build it to be fully read-only, so using errorfs, and then also have it be validated through DM verity. So that's the idea here. We'll see if we actually get that far today. Probably not. So it actually does mention mutability if you want to be completely immutable, etc. So yeah, in our case, we're gonna want it to be completely immutable because it's only gonna be layering on top of opt and user anyways. The mutable data that goes in valib incus, that's gonna go on our persistent partition, which is separate, so that's good. The number of comments to kind of deal with those. There's some way to actually handle updates and refresh and all that kind of stuff. So yeah, it's effectively what we want to use. Now, the trick obviously is how to build that. And I've only read the documentation so far, I haven't actually played with it. But makeOSI supports building multiple images and having images kind of reference each other. So there's going to be, I think, a chunk of this live stream is going to just be me moving files around and trying to make makeOSI still behave. Currently, if you look at the repo here, okay, we currently have our makeosi files directly at the root. So we've got makeosi conf.d, or extra and report, and we've got an entry point makeosi config file here. That's fine, but that's only single image. So we're gonna need to change the layout a bit for that. And that's what we can see mentioned here. They're using makeosi images /base/ something. So we're gonna be moving effectively everything into a base image. That's what all the stuff we've got currently will go in that base image, and then after that we're going to be building a secondary image, which is kind of what we see down here. In our case, it's going to be makeosi.images incus, and depending on the base image, the format will be syssext as an overlay. Base trees, sure, I'm not sure what that does exactly in life, but we'll put that. And then in our case, we're going to be not just installing a package, we'll rerun effectively the same script from earlier, which adds the package repo and then installs Incus. And hopefully that means that our syssext ends up with all of the Incus bits themselves and none of the dependencies. So that should be how that works. Oh, there's a mention about syssext adding more stuff to the UKI. Yeah, we'll see what that does. I mean, it shouldn't, because the syssext should be, I mean, that's still the part I've not played with yet, but it should generate a standalone file for the system extension. It shouldn't go and get bundled into anything. In our case, we don't, so there's a bunch of different ways to do things, but in our case, we don't run with absolutely everything in the UKI. UKI is supposed to really be kernel initrd and then hand off to a system partition that's already shipped under the mverity. So we'll see exactly how that stuff works. Yeah, that's kind of the good and bad thing I think with using makeosi, is that there's a lot of kind of magic and logic it calls all over the place to try and make this stuff work. And when it doesn't do what you want, it takes a bit of extra effort. Alright. So in this case, I've got an example of using it as an initrd. We don't do that. We just want effectively this one. So the first thing I want to try is just reshuffling bits effectively. So if we go back in here, we now know that we need a makeosi.images, I think was the name of the folder here. Yep. So let's do makeosi.images. And then I'm an old schooler who uses Minite Commander, so we can go in here, create a new folder called base, and then effectively clean things up. Actually, I can do make clean for now, so we just wipe a bunch of the stuff. Okay, so we see just what we actually need to use. Test can stay where it is for now. Okay, so makeosi.conf, that one should move, so this one should move in here, along with effectively everything in here except for images itself. Okay, something like that. Okay, how does that work now? Because I can just actually wonder how much of that folder actually matters. It might not. It might just be a convenience. Convenient thing. Let's see. Does makeosi auto detect some stuff? Setting to a streak can be configured in sub-image space. Okay, cool. So yeah, it did notice our images stuff. That's fine. And it's complaining about this one, saying it needs to be at the top level. Cool, that's fine. Setting distribution cannot be configured in sub-image base. Okay, so there's a bunch of stuff that needs to be done globally. Cool. That's fine. So we're gonna need to kind of split things then. So I suspect the content is what really needs to be per image, but the rest can kind of move. So let's see. This guy distribution. Okay, there's a bit of content. So we'll probably need to kind of split it. So let's copy it over and then remove the distro definition. Oops. Let's do this. Cool. And then in this guy, we just want the distro. Okay, so now the distro is only defined on one side. Output and validation. I mean, let's see if it complains about anything else. So just keep moving things. Okay, that's a good sign. Right, so key is already here, and it's building our base image. We'll just see if it fails anywhere later on. So I'm just trying to keep, like, it's gonna make sense. Like, obviously, some of the bits will be shared. Like, you can't have, well, presumably, you can't have a syssext that's based on a completely different distro than you can your base image. So that makes sense. But there's a question around like going all in with systemd and systemd network D and systemd boot. Yeah, effectively. So this is already using systemd boot at this stage. And for network, yeah, it's gonna be network D. Like it's when trying to do that fancy new immutable everything work, especially with macOS I, it's effectively easier to just go full systemd. Which ironically also makes it a bit easier on the security standpoint because you just have one project to keep watching instead of having a bunch of different things. I personally do like netplan as an intermediate for network D because it provides a much more user-friendly syntax with the YAML input. Unfortunately, current packages for netplan seem to pull Python, and I don't really want to pull all of Python into our images if I can avoid it. Like part of this idea is to really keep the image as small as possible, make it easy to inspect, to certify, to validate, to keep track of security stuff on there. So if I can avoid having to put an entire programming language runtime in there, I will try and do that. So we'll see. I know that they've done some work on netplan to try and limit its dependencies, but yeah, there's still a bit of an issue there. All right, so I mean, so far it looks like the image build process is working just fine. It's running through all of the normal stages. We'll just see what it does as far as where it puts its resulting image, if it ends up in the usual spot or if it ends up somewhere else. Like, is it gonna, do we need to update any of the tools, or was that it? If that was it, then that's nice. Then we can just go and directly play with adding the layer. Okay, well, it failed. It failed because of systemd key, looks like. Signing systemd boot binaries, fixing ownership of package manager. Okay. Okay, sign EFI binary, secure boot key. Okay, so it failed to find the secure boot keys. All right, let's see. Like the keys, normally we, okay, so that's odd. Yeah, normally we've got, no, they are here, CRT and key. Okay, they're fine. They're at this level. I suspect it's looking for them at the image level. Is there a config key for where that stuff goes? I mean, I can easily cheat my way around this one. It's not really an issue. Like we can, what would that be? Dot slash and slash, yeah. Okay, make OSI CRT and then images base there, and same thing for key. Okay, so if it's looking for them here, then that will suddenly start working. But there's probably a cleaner way to do this. Actually, what did it do with the image gen? Yeah, it says already here. Okay, fine. I could also change the image gen to just happen within the base image. That might make sense. We're not gonna need the secure boot keys to sign syssext. That is, I don't think. Actually, no, it might use it. It might actually use that to sign the syssext image. Like it needs to be signed with something that can be shared with the main system. We'll see. I suspect there's a macOS config key to just say where the keys are, and the default value is in the same folder. So let's see. I'm also not sure why it's not doing a delta build. It's supposed to. I guess it is, in the sense like the Debian tools are already here. It's just rebuilding the image, but our image is kind of large now since it needs to pull all of the dependencies of Incus, which is what it's doing now with installing QEMU and a whole bunch of other stuff. It's actually, no, I think it's, yeah, no, it's rebuilding the Debian layer. What is it doing now? Let me check. Like it's rebuilding the tools over and over again. It shouldn't be doing that. I thought we had logic in build to, yeah, there's a cache there that's specified to supposedly avoid doing that. Okay. Anyway, it's not a huge data as you've seen. It builds the whole image in just a matter of a couple of minutes. It's not a particularly big issue, but if we need to iterate through that signing issue more times, it's going to become a problem for sure. Okay. So just getting the kernel stuff in place now. Okay, I think it failed soon after that because effectively installs the kernel, tries to build initRD, puts the files on the EFI partition and then signs them, and that's when things went wrong because it couldn't find the key. So hopefully this time it will find the key. And if it does, then we can do that as a commit for effectively moving what we have to a separate base image, and then can go and add this, like try building the syssext layer for Incus itself. Alright. I don't remember exactly where it failed. I thought it was around here because it's doing the partition and signing and stuff here-ish. Okay. I think we might be past where it failed last time. This I'm hoping. Okay. Because it's literally installing, like it looks like the initRD. Oh no, it might have failed here last time because it's doing the initRD and the UKI step now, I think. Let's see. Signing. Okay. Measuring for the TPM stuff. Okay, cool. And it's not failing. Okay, that's good. Creating the partition table, and it's gonna spit out an image. Yep, image was generated. What's it doing now? It's installing more stuff. Because normally, where was it? Yeah. OS image raw, consume 700 megs. And now, oh, okay, it's doing the default image. Okay. Okay, we don't want that. But it's effectively building a secondary image because it couldn't see anything as being defined. Okay. Cool. So it built a few more things than it should have. I wonder, because the image is called base, not default. And presumably there's a name of an image, something we should mention. Oh, we should rename base to defaults to make it happy. Let me just get the full help for the macOS syntax again. Yeah, so there's a question around how we're gonna be handling, all of the updates and all of that kind of stuff. So the plan is to actually have a daemon running on there. Currently, the image just boots and there's like no shell, no nothing. The first stage we're gonna do now is effectively getting it to a point where it boots, it's got Incus daemon running, it listens on the network, and then we can interact with that. But the next stage after that is going to be to implement a small daemon, probably called Incus OSD or something like that, because I'm not great with names, and have that daemon run on boot and effectively be plumbed through the Incus API. So you should be able to access the Incus API with normal authentication, normal everything, and then hit /OS on the API endpoint, kind of like what we do with the UI. And then anything underneath that will forward straight to that OS daemon, which can then let you do system level configuration. So things like reconfiguring network, handling partitioning, handling like extra disks, encryption, setting up your TPM, your LUX backup key for the encryption, but also check on whether the system is updated, both the main OS image, which is going to be handled with systemd-sysext, and the Incus layer with systemd-sysext. So I think the idea for both of them is we'll just go kind of the very simple route initially, where we're gonna have GitHub Actions generate those images on GitHub directly, and we should be able to then publish them as automatically through GitHub Actions as a release, and then we can look at the endpoint on the GitHub side to just pull those images from there. So we don't even need like an update server or anything initially. We can just do it all through GitHub. As we have this thing become more official and like production ready, we're probably going to be moving that to an actual probably to our website download page or something, so it's not all dependent on GitHub. But that's the idea, and that system daemon will handle a bunch of things for us. I mean, I still think we're gonna have the need to do the initial provisioning for just like how the hell do you connect to the network. So the idea is probably gonna be to put a YAML file or something like that on the ESP partition, so the EFI system partition, and then on initial boot. So if we've never created the persistent storage or anything, we're gonna go and read that file and apply that as the initial config. But yeah, the idea is to not read it ever again afterwards, so that it doesn't let you bypass effectively all of the security bits. Okay, where's the man page? Yeah. Okay. Because like for the syssext stuff, so there should be like effectively an image name or something in there because it's mentioned default. Then okay, make OSI, the name of the image is preferred over image ID. Okay. Output. Okay, so it uses the output as the name to use for generated. No. Defaults to image or image ID specified. Okay. Image ID equals. So there's an image ID thing. I don't know that this is what it uses. Configures the image identifier that accepts freeform string. So also passed to script. Image ID is automatically added to OSB release. Okay. I don't know that this is the issue. Huh. I mean, I kind of tempted to just rename that image from base to default to just take care of that particular problem. Because the problem that in a man page looking for default is usually a bad idea. There's a question about like how to trigger the syssext update. I don't actually know. I haven't actually looked at that yet. If there's a systemd either dbus or varlink API, we can use that. Otherwise, we can also just have the system daemon shell the systemd-sysext command to do it. Okay, so that's default. Yeah, it's gonna be a bad idea, huh? I'm just saying if anything jumps at me as far as the name, but I think it's gonna be a bad idea to try and look at it that way. Okay, well anyway, let's just try the easy way out. So let's just go ahead and move make OSI images base to make OSI images default. Okay. Clean up the mess and rebuild things. That's not a good sign. Removing output files of default image, removing output files of default image. Okay, so it's even with the image being called default, it's still doing it twice. Okay. Yeah, I don't think that's gonna help us. So how do we make the base image not do anything, basically? Because like this technically has a config. Is there just an argument to make OSI that lets us tell it what image to build? That might be the easier way, actually. Make OSI build is what we called. So let's see. Yeah. Like, why do I need sudo to get the help? That makes no sense. Okay, it's because it doesn't do help properly. Lovely. Okay, so let's just ignore that then. And go look at the man page. thought it was just a normal Python command, which would, you know, normally have proper argument parsing, but apparently it doesn't. Make OSI build. How does one build a specific image? Okay. Yeah, so there's an incremental thing I'm not passing. That's probably why I'm rebuilding everything. It's fine. Okay, so that kind of goes over everything it does. Did I miss something obvious? It feels like I should be able to tell it what image you actually want to build, but apparently not. Definitely missing something obvious, I think. His own settings parameters, this command is the default, if no verbs there. Okay. Just as it goes on. Build specific image. That's not helping. Yeah, definitely not helping. Like I could potentially put, like there might be a way to set the base image as being like empty, useless stuff. So it doesn't mess with the default. Okay, again, what did they say for the syssext stuff actually? Where's syssext now? True. Yeah, I can't find anything. Make OSI syssext. Okay, where's that doc? Okay, and the docs, but then the rest wasn't. Okay, sure. Creating temporary directory with a base config with some shared settings. Okay, sure. Output. Okay. We're assuming executing inside a temporary directory. Okay, now let's with the base image. Okay, but okay, format directory. Yeah, don't care about the root privilege part. And as we have a base image, we can define syssext that builds on top of this following. Sure, but it still doesn't solve the issue that like the base image will build something even in that scenario. Output directory, yeah. Okay, anyway, I can figure that out later, it's fine. For now, let's just try and create the layer and then let it generate a pointless image every time. Just kind of frustrating, but okay. Because like it doesn't let us put that in an image. But then if we put it in the base and it builds this pointless image, okay. I should actually just move that to the main macOSI instead of in .d, because if it's the only thing in .d, it's kind of pointless. So let's just move it here. Okay. Just hoping it wasn't gonna make that much of a mess, but fine. macOSI images, it's add that. It should have seen a bunch of renames, but it didn't. Okay, fine, add everything. Okay, renames, we're adding distro, renaming, deleted. Okay, that seems fine. So let's just do switch to using macOSI images. Okay. And project and type. That's great. Okay. Cool. So now we've got that base image in place. Let's go and try to set up a secondary image. So here we just want an image called Incus, and let's just make it very simple for now. So make osi.conf. And for the secondary image, so there's a dependencies thing here. So let's just pick up the same thing. So dependencies on one base, syssext, overlay, show. Then we won't quite do, what do we do here? I mean, technically I can do packages Incus. It's kind of pointless. It's kind of weird because it's gonna pull Incus from the Debian package instead of the archive, I think. Actually, no, it's overlaid, and the main image already has what we need. Like it already has a repo set up, so that might actually work. Maybe. Let's try it. Go ahead and make. What is it complaining? Setting. Oops. Yeah, it's not happy about that. Okay, hold on. Make OSI images, Incus, this guy. Okay, can I just do this? That'd be nice. But probably not. It wants to know where we're gonna be doing the publishing, and there's no, like, it's because we don't have an output folder thing defined here. Okay, so if we just go and do this. I think I might already have the cache directory stuff set up somewhere. Cached. Oh, apparently I did not. Okay, fine. Then if I don't, that's fine. Let's just add that to the previous commit. Add a change for that. Okay, make. Yeah, it's not complaining anymore. Cool. So let's see. It's gonna, in theory, go ahead and build the base again, build the layer on top of it again. Gonna have to see if we can change that somehow, because obviously it would be kind of nice if we could rebuild just the syssext layer instead of rebuilding everything. But I need to look more about like how do we trigger a specific build, because I also want to get rid of that pointless default image it's spitting out. So it's probably going to be related to that. So anyway, while this is happening, let's go look at the systemd-sysext command page a bit. So as mentioned, like systemd system extensions can be shipped in a few different ways. We can ship them as just a plain directory, which is not what we're going to do, because if we do a plain directory, we can't like measure it. It can't be signed. It can't use dmverity, fsverity, any of that kind of stuff. So we're not going to do that option. It could be GPT partition. Probably not. I mean, like as a disk image with a GPT partition is fine. We might just not put it directly in the main partition table because we're gonna want to be able to ship those around. But that's fine. And as I said, like they're actually looking for those extensions in like varlib extensions. So when I need to have them land on there, that's okay. The daemon we're building can handle that easily enough. I think there was also mentioned like around the tooling. Yeah, there we go. So there's tooling to go and look at the system extensions on the system to actually apply them, I guess. That's what the merge does. It configures over the FS for us, and merge removes them. We can do refresh, which would presumably do the unmount switcheroo to like remove, put the new one in place effectively. And that's fine. We're just gonna need to do the timing right, because we can't do that while fixes are running. So effectively we need to like stop all of the Incus stuff, do a refresh, and then we should be back in business. That's another thing to kind of look at, is how systemd is gonna handle systemd units being on there. Like it's effectively meant for that, so it should be fine. You should handle it, but I've not played with it yet, so we'll see. What we would like to see, obviously, is get the syssext, and when it gets merged into the system, the extra units for Incus will show up. Then we want those units to automatically start as if the system just booted. And then when you do a refresh, the units, the running ones should stop. That's where we're gonna have a bit of a trick we'll need to probably pull there. Because if you stop every single Incus unit, you're gonna stop every single instance as well. And we definitely don't want to do that. So we're gonna need to potentially trick things a bit so we don't have that issue happen for us. It's also gonna be a bit odd because the Incus OSD will be part of the base OS, that's fine. But Incus itself will be part of that image. And so during a refresh of the syssext, you will lose API access to the OS daemon temporarily. It shouldn't be an issue really. We just need to make sure we've got a good way to restore that access if needed. That's because we effectively want to have a single API endpoint for the system, which offers both the Incus API and a way to talk to the Incus OS API. That just makes it a lot easier from like a firewalling, validation, authentication, authorization standpoint. But obviously, when you refresh Incus itself, that comes with a slight downside. We may be able to make Incus OS effectively be able to take over. So yeah, it's effectively we might need a way for if IncusD itself can't come back up because there's something wrong with the system extension or something like that, to effectively have the Incus OS daemon itself pick up the keys from the Incus persistent storage and start back with just a minimal API, effectively as a recovery mode, being like, hey, Incus doesn't work. There you go. The API, the OS management API works, and you can try and fix it. So that's kind of the idea, but that's for a little bit down the line. Let's see what's going on here. Okay, so base image built 2.8 gigs, 700 megs. Base tree not found. Okay, so it built the base image and then promptly failed to find the other one. Okay, why? Okay, so that's why it published it. Make OSI output os-image.raw, and the other one went and looked for base, which yeah, not gonna work. Okay, I think that's because the name here is overridden in our config. Okay, let's see what does it put in there. Okay, so we do have a thing called OS image, which points back to raw. Okay, all right, so that's the issue. It's just because we renamed the image, we need dependencies base is fine, but the base tree is actually OS image instead of base. Yeah. Okay, let's go and see if that fixes it. And just because we rename it to OS image for kind of convenience, like if it was called base, that wouldn't really tell us what it is. So then apparently make OSI doesn't know to go look at all of the configs of what's defined as the parent image to try and figure out where it lands and what name it has, which is presumably why we've got that config key that actually overrides the base tree. All right, so building this stuff again. I'm hoping this works and that we get a syssext. I don't know that, like I don't actually know how to ship the syssext into the system and getting merged yet. But if this build works, then we can try and figure it out quickly. Otherwise, I'll figure it out after the stream and give an update probably in next week's live stream. So yeah, it's starting to look pretty good. Like the base image is pretty much functional. There are a few more things we might want to put in there. Things like oven, things like Ceph, to be around for anyone who needs those. Currently, okay, still complaining. Systemd-sysext, okay. Installed on the whole system. Well, clearly it's not, but where does that one come from? Because that's gonna be a problem. Systemd, let's see. Yeah, what provides this thing? Systemd container, okay, sure. Let's install that. I don't know if it actually is enough to just put it on the base system, but who knows? Let's see. Make, okay. Just checking what it's doing now. Okay. All right. So as I was saying, like the base OS image is mostly good. We're missing a few bits we might want to add, like file system wise, network wise, and still need to add what we need for basic network connectivity. Like the daemons are all there. There's just no network config right now, but that should be okay. And the main big piece really on the base image side is gonna put that Incus OS daemon, which I've not actually written yet, to handle the first boot provisioning and then integrating that with the Incus API. Then the second layer is what we're trying to build now. So that's the system extension with Incus itself. Hopefully that's pretty straightforward when we end up with the right bits in that image. And then it's going to be mostly around plumbing it so that we do get the systemd units showing up when we actually do apply the layer. And then start them and have a way to actually refresh and switch to a newer version of it. So that's that layer. Okay, it failed again. What did it? We don't need file system. Yes, that's the point. I'm so confused. Like, yes, it's an immutable base image. Why are you trying to remove stuff? Like, it's supposed to be the base tree. Okay. I don't think the systemd-sysext documentation was helping us much on this one. That's the base, that's the one for syssext base. Okay. Points out to our base image and overlay. Yes, instruct make OSI to only package the files added on top of the base tree. Yes. Okay, but like, why are you trying to remove stuff from it? This is really weird. Okay. Yeah, there's some lack of documentation around there for sure. Not too sure how much I can still keep digging during live stream because that's gonna get pretty annoying to watch pretty quickly. Today I was trying to remove, well, yeah, I mean, what I'm seeing here is that this is most likely where it mounted the base image. So it took, like the base image itself is a, if we go look, make OSI output. Okay, the base image here, that's a disk image. It's most likely mounted this, which is fine. And then it's supposed to do an overlay on top of it and install the stuff we want and then pick up that overlay and that becomes our image. Instead, it looks like it's actually trying to modify the stuff that it mounted from that image, but that image is using RFS. It's all read-only. There's no way you can modify anything. That's the whole point. So I don't understand why it's doing that. Like, did it actually at least clean up its stuff properly? Or do we have a bunch of mounts and stuff all over the place? No, it cleaned up things properly, so that's good. But yeah, if you go and look at the make OSI output OS image raw, right, it's got the ESP partition, it's got the actual root disk, so it most likely mounted this guy, that's the read-only partition. So it most likely mounted that, which is fine. Then it's supposed to add stuff to it and pick up the changes. And instead it tried to wipe the entire tree for some reason. So I need to debug that. Like the problem that the example that they provide for syssext is using like a file system tree as a source. It's not using an actual image. They do mention, I think, in the man page. Let's zoom. Okay, yeah, here we go. we use directory output format here instead of disk output so that we can build our extension without needing root privileges. Okay, fine, but I'm running macOS I with root privileges, so I should be able to use a disk, but apparently that's not working. So I need to figure out why. There's probably some way around that. Like, I'm obviously not the first one using macOS I for this kind of stuff. There are a bunch of other distros that actually use this to build most of their images and overlays and that kind of stuff with macOS I. So it's mostly going to be a matter of Googling around for anyone else that run roughly into the same issue, or any of the other projects that use macOS I, and see how they're building their syssext. Like Prism, like there's one way, like in theory, there's a way I could try and do this, which is kind of putting another layer where like base is not an image, base is just a, what do they call it? Directory as the output. And then you pick up that as the base for the Incus syssext, and then you pick up the same base and spit it out as a disk image. That might be the way this is supposed to work. That seems a bit odd. Like this should just work. And it tried to do most of it right. Like it clearly figured out it's also a disk partition, figured out how to mount it. I don't have enough history to go and see if it actually installed the packages we asked it to install. It might have. It might have gone as far as generating the overlay, and then it decided to wipe the tree instead of just unmounting it, and that then failed everything. So anyway, we're effectively at the top of the hour now, so we've been going through this for an hour. I'll probably leave it there and do a bunch of kind of research and unblock things from there. But yeah, that's kind of the first steps towards getting syssext working properly. I'm hoping to get that working out, well, hopefully today, maybe tomorrow. And that means that then next week, I can hopefully do another live stream again on Incus OS, but this time focused on sysupdate, which is the other piece we need to put in place. With sysupdate being effectively the AB update mechanism. I don't think it's gonna impact macOS I quite so much. It's mostly gonna be around like, well, this partition layout will be a bit different, and then kind of doing a test image that has two versions of the same image on it, and then see if we can go back and forth. But yeah, that's gonna be the idea. And like we can see here, like some of the basic commands and stuff around systemd-sysext. It kind of looks like there's some stuff that looks the same, like list, and I think there's like a status command or something that kind of lines up with the sysext stuff. But then other than that, it obviously supports actually pulling an image, validating it, and then triggering the reboot onto the new image. So we're gonna want to try and get that working, because that will then mostly give us all the pieces we need. The remaining piece is gonna be the management daemon. But yeah, like I want to get as quickly as possible to a point where it's possible to grab an image from us, install it on hardware, and then boot the system, have Incus up and running, be able to interact with it, and most importantly, be able to detect that there is a new update, either to Incus itself or the base OS, and apply the update. Because once we get the update mechanism working reliably, then it makes it a lot easier to iterate and push fixes to everyone. Until then, we're effectively limited to people manually building images on their own machines and showing them at test VMs, but never actually being able to use that for anything because we're missing an update mechanism. All right. So enough rambling. Hopefully this was useful to kind of look at some of the behind the scenes, macOS I, systemd components, all that kind of stuff, how that works. I'll do a bunch of research now to figure out why the overlay generation didn't work, and also figuring out what's going on with that default image thing it keeps generating, because we don't want that. And hopefully can sort out the two of those issues pretty quickly. Push that to GitHub, and then can give a status update on that and start looking at sysupdate next week. All right. Thanks everyone for watching. If you've got any questions on this, feel free to leave them down in the comment section below. I don't know that I necessarily know the answer. It's still pretty new. I've done a bunch of Googling and reading code and everything to try and figure out a lot of the macOS I stuff. I also happen to have good contact with its author, so that's always the the other way to figure things out. If I can't figure it out with a bunch of Googling over a couple of hours, I'm just gonna go straight for the source and get it that way. All right. Thank you all for watching, and see you next week. Bye.